We're going live now.
Hello everybody, thank you all for coming. This is the third edition, I think, since we started the data engineering meetup in Copenhagen. I'm very happy that you're all here, and we are very grateful that Dixa decided to host us today. I used to work here, and I'm very happy that that connection has been made. Yes, today we have two presentations, one from Dixa themselves and one from a fellow from Maersk. I'm very excited to hear both. We are also giving away 3 licenses for JetBrains, and we're going to have a digital raffle. So yeah, I hope you enjoy yourself. Go ahead.
Hello everybody, my name is Victoria and I'm a senior data scientist over here at Dixa, and I will be talking about, is this working? Oh, of course it isn't. Technical difficulties. Oh, there we go.
Where? I'll be with this and slide it.
Let's start from here. Just. Awesome. So now that we have figured out the technical difficulties, what are we, if we need to have those anyway? Is it working now? Wonderful.
Give it to me.
So with this, I am going to talk about some of our projects that we do here with AI. And I'm going to focus really very much on the practical side of things, on the little tidbits that actually work or don't work, practicalities that you need to consider, and stuff that you encounter as you work with these types of projects. I'm sure many of those you've already seen yourselves, and if not, then at least it would be something to discuss and think about. This is what our program looks like. We're going to start with a little bit of introduction to Dixa. I'm going to quickly present the team. Then we're going to look into some technical details about one of our projects. And this is going to lead us about how an AI team fits into an organization and how going through those technical projects is only part of the story. And the big story actually is how your team works with the rest of the organization in order to deliver this project and make it something real. And then we'll do a Q&A. Welcome to Dixa. So the thing that we do is what we call a customer friendship platform. Or to put it more practically, whenever you're part of a company and you do some kind of support, whether it's customer support, whether it's technical support, whether it's something like this, you usually have to take care of several different channels of information. So there is email, there is phone, there is messaging, there's all kinds of ways when someone can come to you and complain about it. And keeping track of all those things at the same time is, it can be difficult. And what we do is we provide a solution where everything comes together. So all of those channels available on one platform, subscribe. As part of this platform, you can imagine that we use a lot of language, a lot of text, and a lot of opportunities appear there for AI, and this is where we come in. Our company was founded here in Copenhagen. It's growing more and more and more. We're getting bigger and bigger, and that's good, and hopefully we'll continue to grow. This is our team. You'll notice 2 empty circles. These are 2 people who are just about to start. The rest is people who are currently making a lot of things possible. Mostly we are creating a lot of difficulties for the rest of the teams, because that's the purpose of AI. We have a master plan of using all of this text data that I mentioned, all of this language, to build a lot of language-based things. We have one big tech tree, so if you've ever played, this was a little bit inspired by games like Diablo or Civilization, to allow us to build a very big timeline of where things go, with starting from let's say a couple big language models and all the things that they unlock as you develop on this thing. With that said, I'm going to start with one particular example that's kind of a foundational project, because it also reveals a lot of the things that appear as a problem, especially when you establish a new team. I'm sure many of you are part of a very new data science team within a company, so there's a lot of difficulties that you need to go through. The future we're going to look into is our auto-completion project. You know how this works. Each one of you has used LinkedIn, has used Google Docs, or has used any kind of feature that provides auto-completion. Turns out that behind the screens there's a lot of little details that you might want to get right in order for this to work seamlessly and good enough for you to use it. At the very core of this is a language model. We're using a very standard approach with a three-part model. It's basically a transformer that we train on a lot of input text. We are using all of our information, so we have a lot of emails, a lot of chat conversations, a lot of WhatsApp conversations, and many things like that. We take all of that, we get the embeddings. In the case, we are using pre-trained embeddings because nobody has the time or money to build something as big as, I don't know, Google. And then we train our own model that can generate a text. It's a language model. All of this needs to go into a service that delivers some kind of that works behind the screen, the scenes, to provide the feature that we want. Because after all, the model is just one side of everything. What we're using is actually a very simple, more or less standard standard architecture. I'm actually not going to bore you with this, because if you have ever implemented a pipeline, if you have put a model in production, you're familiar with something similar to this. What matters is the problems that arise as you're putting those things out there, as you're making those things, because that's where making something alive actually comes to life. The data is the first part, of course. If you want to build a model, you need some kind of data. If you want to generate some insights, you need some kind of data. And the problem is that in a lot of places, when you go in a new organization, you kind of have to figure out who has the data, who owns it, where is it. Those are all things you need to consider from the very start. You need to do a lot of detective work, and that's just the start. The second part is how are you going to store it? Because on a lot of places, in a lot of places, whatever storage you have, whatever data warehouse you have, is actually not built with the needs of data science or machine learning or anything like this. It's usually built to just store the data, to put just the heaps there. Everything else, analytics, data science, comes more like an afterthought that, hey, we have these heaps of data, let's try to do something with it. This means that very, very often you need to come up with some kind of a solution to take this data in some temporary storage, use that, probably AWS, probably not. You're going to make a huge mess out of it. Eventually you're going to grow to such a level that you need to probably implement something like Airflow or Pachyderm or something like this to manage all of this data. But here's the question, do you start with this immediately, or do you just start with buckets? When is the time to start with using all those tools? Because they are quite heavy and can be expensive. And then you get to start pre-processing the data itself, which is a mess in its own. You need to figure out how to handle privacy, how to handle garbage. You need to be very aware of the limits of your own libraries, because one of the things that we encountered, for example, is trying to anonymize our data, which is, of course, absolutely necessary, especially when you're working with personal data. that a lot of the stuff that's out there, for example, Spacey or NLTK, are actually quite bad with recognizing personal information. And you might need to figure out how are you going to work around this. Is there a way to fine-tune those models? Are you just going to throw this data out? What are you going to do with it? This is a whole big discussion that you need to figure out based on the requirements of your project. And of course, one of the things that I keep encountering again and again, people are a little bit shy when throwing out data. Sometimes, probably more than half of what you get is actually going to be garbage. Make sure you throw that out, because what you want to be doing here is you want to progress to a data set that you can use now, that you can make a product now, so that you can keep on iterating. Also learn regex if you don't know it. It's just fucking magic. It's black magic, you'll go insane, but it will save your life. Data is of course only one side of things. The next step is the modeling. The big question is whether we want to use something that's fine-tuned, whether we want to use Hugging Face, or whether we want to train something on our own, whether we want to have control over every little tidbit, or whether that doesn't matter. We just put it into the bucket, we click fit, and then it's ready and we put it out. And this is a very big consideration, because when you take a pre-trained model, you need to be very aware of what stuff is out there and what's it trained on. A very nice, interesting example with this is speech-to-text data. A lot of the speech-to-text models that are available as open source out there are trained on libraries that are someone just reading an audiobook or something that's very, very clean. And when you take a phone conversation, that's rarely going to be like this. Especially if someone's having a phone conversation on the street, good luck transcribing that based on whatever audiobook you decided to take by someone with perfect Oxford English. The other thing is that if you want to train your model, that's going to be expensive. So you need to kind of think about how much you want to train, how long is it going to take, and if you're going to be retraining again and again and again. At some point comes a time where it's much cheaper and better to just get your own GPU rig. Of course, if you want to get your own GPU rig, you need to plan for pandemics, supply chain problems, and a bunch of crypto bros buying all the GPUs, because that all gets in the way as well and rises the cost. All of these are things that you need to think about within your team whenever you're putting something out there. And that was actually the easy part. The fun part really is when it comes to deploying this and scaling it up. And the fun part is because this is actually not really a data engineering job. This is not a data science job. This is a job that needs to involve other teams that are involved with front end, other parts of back end, everything else. And you need to go and you need to talk to them, you need to bully them in order to dedicate their time, because otherwise they will not prioritize you, and no matter how good of a solution you make, it's not going to see production. You need to have very clear idea of what you're trying to put out there, whether you have some criteria about speed or some other metric, and you need to be sure to have a very clear definition of what your trade-offs are. Is accuracy more important, or are you doing something in real time that you can afford for it to be a little bit less accurate, but it's fast? Depends on what you want. The big thing that we have encountered here as well is that it's very easy to make something for training in terms of pre-processing, but when it comes to inference, you have to replicate this exact same process of pre-processing the data. Because if you don't, you run into this problem where the data you feed into the model in production is very different from the data that the model has seen in training. So whatever you get out of the model is going to be garbage. So this is something you need to start from the very moment that you decide you want to do this project. You need to outline how this is going to work in inference, because training, again, is the boring, it's the easy part, it's the inference that you care about. Of course, you need to figure out how to replace models. Most of the time, it's just copy-paste, putting it in AWS in the buckets. We have model 1, model 1A, model 2, model 3, and so on, at least initially, until some point comes where you create 5 different pipelines, each of them slightly different from the previous, none of them doing exactly what you wanted to. So this is something to consider as well. Speaking of metrics, here's a really interesting example. Accuracy, of course, is not all. When you're building a language model, you need to consider some other metrics that gives you an assessment of how good actually the model is when it comes to talking with speech and talking and using language. So we have an example where we have some input. Our generated approach responses. We appreciate this feedback. I have passed this on our tech. And that's a very valid response. So if you read the input, that's a very good, it's fine. It's all right. The expected response is something very different. It says, we appreciate this is frustrating, however, with stores selling out quickly, blah, 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 some explanation. So this actually achieves a very low Meteor score. So this is one of the metrics, I'm not gonna go into details, but this actually achieves a very, very low score, even though it's a very valid response. So don't rely on just the metrics. Go and look at the model, look at the outputs, always keep an eye on it. And I know this is going to take a little bit more out of your time, but it's essential in order to monitor this model to make sure everything that you get on the end is actually good enough. And then we also come to the end user side, because in the end, I don't care about your metrics, I don't care about anything else. I care about that your user is happy with what they receive and what they see. And even though you might have good results, even though you might have good scores for like language quality or whatever, if whatever the user is seeing and not using it, if the design from the front end is bad, you failed at the product because nobody's going to use it. And this is also something that may come up in a conversation about how do we evaluate this project, how do we evaluate that what you did on the data side is good. You might run into an issue where the design is crap, whatever it did was good. You have a couple of conversations, oh, we decided the project is crap, we close the project. When the problem was not what you did, the problem was the design. So this is also why I think that all data people should be involved with whatever design, whatever UX part is happening from day one, from the very start. Because most designers, most UXers, most front-enders, most people involved with this have no idea what the capacity on the data side is. They have no idea what you can do. They have no idea how you can do it. They have no idea of the dark magic that you have. And they need a little push with that. It's also good to think about how to get feedback from the users, because the way that they use the application is essential to how you're going to iterate and improve on it. And again, this is why you have to be involved with the UXers and you have to push them, because you need to see what is the user seeing, what is their feedback, what are they saying, how do they want to improve on this. And this is also essential when it comes to handling failure, because your model, of course, is going to fail. This is like no questions asked. It's going to happen. So you need to have a failback plan. Whenever your model is giving bad predictions, how are you going to handle it? How much are you going to show to the user about this? Again, another thing to think about and to figure out. It's all about finding the best way to fail gracefully on the model side. And this is essential for whatever product you're putting out there, whatever feature. It's essential for its adoption. Otherwise, it's not going to be adopted at all. All of those that was just a bunch of questions based on different things that we've encountered. So things that I have encountered throughout my career, things that I have encountered here, there, everywhere. And these are things that are purely technical questions. But when you're a part of a data team, that technical side is only a part of the whole, because your team is a part in a bigger system, in an organization. And very often, getting things done also depends on how well your team fits with the rest of the organization. And you need to think, what are you doing there? What is the purpose of your team? Some data teams are there only to do analysis, to move data from one point to another point, to build data lakes and so on. Other teams are out there trying to train models, do complex machine learning tasks, create forecasts, predictions, and so on. In essence, all of this boils down to several different things. Are you a production team? Are you doing production? Or are you a research team? Are you doing purely research and development? Most teams have two different sides, and those sides come in contradiction with each other, because the experimental side is purely experimental. It has the potential to not work, but it might work. And then we also have the thing where you also need to deliver features. So this is something you need to figure out for yourselves. Where are we on the two scales of research versus production and features? And with this related, you need to figure out where are we getting our information? How are we coming up with new things to solve, new things to do? Are we looking outwards? So are we going and checking what we have from marketing, or what other companies have done, or what's out there in the literature? Are we looking inwards? Are we solving features and problems that people from our own company come and tell us that we have this problem, we have that problem, how can we solve this? Are we looking to the future? Are we trying to come up with new technology, something that's going to work down the line, is going to completely change our business, completely disrupt everything, make us the one and ultimate go-to source for whatever you're doing? Or are we looking to pass data and coming up with analytics reports that can be used to tweak the business here and there, distribute resources better? All of those are questions that fall under the general umbrella of data science. So you need to figure out where your team is on those things, and you need to be very aware, because when people come to you from other teams, they're going to have different expectations, and it's on you to set those expectations. And when you're doing this, here's something that you might most likely are going to experience, is that very often you discover that it's very difficult to get resources from other teams. They might be completely busy. I think I mentioned this several times already, so I need to mention it at least once more. Very often you will depend on another team, and they will say, yes, we'll do it, and they will dedicate the resource that you need, but also it will be so low on priority, you're gonna grow old before the time comes for this to be implemented, right? And that kind of sucks. It could be the case that your team is not integrated. So you have a data science team, you have a data engineering team who sit somewhere in their own corner. Everybody knows that those are the data weirdos, but nobody ever talks to them, nobody invites them. They're not included in the big meetings, they're just doing their own thing. And if you're not part of the bigger whole, part of the bigger system, you cannot expect that the system is going to consider you in any way. I mean, of course, if you just want to get your paycheck and go home, that's perfectly fine by me. The final thing that comes out of all of this is the wrong scope. So whenever the wrong scope is more of an outcome of all those things, and this is when you come up with a project that nobody needs, nobody cares about, it's not relevant to the organization because it's either too far out there or it's too small. So that's also kind of a thing. For me, all of those things, however, are part of a bigger whole, and that is the underdeveloped communication channels within the organization. So where the data science team stands, it needs to have channels to everywhere else. It needs to have channels to whoever's doing the management, the PMs, the CEOs, whatever, so you can rely on those people to go and to apply pressure when you need prioritization. You need to have friends in all of the production teams so that they don't hate you when you go and say that the boss says you need to come and do this for me. And also you need to be friends with them, because this is where a lot of your features are going to come from. This is where you're going to get you're going to understand what problems are within the organization that you can solve with whatever you're trying to do. you need to bring people together. Whenever you start a project, try to consider who else is going to use this. Like, do you have UXers that we're going to need? Do we have people from the very start, from something completely unrelated, maybe marketing that one day is going to touch this product? Bring them along, ask them what they think about it. They might have an insight. If not, you're just going to be building relationships, and this is incredibly important. Likewise, involve people early, especially from other teams, from other departments. Don't just go on to develop a model, put that model out, and wait for months before you add other people. You need the insights of everybody else now. And the best way to secure this involvement of other people is to make sure that you have common goals. Make sure that at a higher level, whether you're using OKRs, whether you're using some kind of KPIs or other kind of metric, by far the best way to make sure that they actually come and help and are involved with you is to make sure that part of their goal involves you and whatever your project is. This might require a little bit of bullying your managers, but that's all right. You're probably 3, 4 and they're only 1. You need to also be very proactive. You need to go out and you get involved in every single meeting, design meeting, new meeting, feature, whatever it is, trying to come up with new things, because again, the people there don't know what is available, don't know what is possible, and they will come up with a new solution without including you or whatever you can contribute to it. So you need to be also an ambassador for your own team. And this kind of sucks because I don't know about you, but I'm a little bit introverted. I don't feel comfortable going out and barging into people's meetings and so on, but you kind of have to do it. And then you need to be following up. So whenever someone gives you a promise, whenever you're part of a meeting, you go after the meeting, you talk to them, you talk in addition to that, you try to get involved in the next meeting, always trying to get involved. And that's about it. As the technical part, and that's the organizational part. I will try to send this presentation. Hopefully it's going to give you a little bit of food for thought. Yeah. If you have any questions, I think that's the time.
I thought it was a really good presentation. Especially the part where you talk about how you have to be very close to UX, the product, and engineering at the same time. You can't be an island when it comes to data. I'm very curious about kind of the scale of the things you're doing. So maybe you can give me an example of, for example, how many service calls do you have a day, or how many times do you train the model a day, or
we usually don't train our model a day because training a single model for the auto-completion takes a couple of days. It's a big language model. We have, I think, several thousand conversations a day at least. I'm not really familiar with the numbers, quite a bit. I can have a look. We have a big screen downstairs with all the different calls and everything. I can have a look and tell you later.
How do you tackle the anonymization?
Sorry?
How do you tackle the anonymization?
That's a wonderful question. So there are several things that are involved here. First of all, we use only whenever we have text, we're using text data, of course. Whenever we get text data, we keep only the text, so we get rid of all of the other fields that give us information about what company is coming this from, what company this is coming from, who sent it, who's receiving it. That's the first step. The second step is to just use a bunch of combination of regex and a couple of libraries to get rid of all the identifying information such as names, addresses, and things like that.
Is that applying to free text as well? Free text fields? Okay. Thanks.
I have 2 questions. First is you mentioned that it is quite hard to actually, in the journey of creating machine learning or AI, to have storage that can answer questions that machine learning or scientists want to ask. What is the storage that you use currently?
Currently, everything we use is in AWS. So when we started, we were just, even now, I think we're still using buckets. And initially, of course, everything starts with a couple of scripts, then we moved on to Apache Airflow to handle moving things from one spot to another. The organization itself is built on Dynamo, on the Elasticsearch and things like that. And again, everything there is built with the mindset of this is what we need in order to build this service, and nobody ever considered that this is going to be used later for analytics or for AI. So these types of considerations are not something that's included. So we need to do a lot of transformations and combinations of different tables on top of that.
All right. And what about the machine learning models versioning? You mentioned something about that. Do you do something with regards to it? Or?
Currently we don't, but we just started using MLflow, and that's been wonderful so far.
Thanks.
I have a question on the people side, right? I think when I see, when you show the teams, right, I see the title mostly data scientist, machine learning, I don't know, engineers, stuff like that. But you also mentioned actually there are a lot of tasks not necessarily related to generic data science tasks, right? Or not, it's more, how to say, it's more like a marketing task, like you're marketing yourself, right? You get engaged, you get involved. How do you see that? Like, is it, because I know also every company, data scientists doing different things, right? Depending on what you mean. But what do you see the roles? Like, does the data scientists all have the same role? Or is even make sense to have separate role that is not so much focusing on the actual data science job, but more on the engagement with the stakeholders?
I think that data scientists and engineers need to be able to go out and talk to the other people in the organization as well. They need to be involved because, like, when I work on my everyday job, I might need something from a database that I know nothing about. I need to know who to talk to, and I need to know that this person is my buddy, that we've had a couple of beers, and I can go and bother this person during their workday so that I know that they're going to pay attention to me and give me and help me out with whatever task I'm doing. At the same time, you also definitely need someone to go and proselytize, or someone to go at the planning meetings, management meetings, maybe someone to do presentations or something like this. Unfortunately, we're all very limited in human resources, so you're going to have an insanely huge budget. You're going to have to be DeepMind or Google in order to have enough room for more people dedicated to this. So kind of, you have to be a jack of all trades. That's the thing with all those machine learning ops, data ops, and so on. You already are doing back-end, front-end, machine learning, deployment, and everything else. Well, congratulations, you also have to do the social stuff and the marketing. Yes?
Thank you for the talk. So you analyze text, right? And emotions in a text can be difficult to interpret at times. For example, if someone is being sarcastic or funny, can be difficult to interpret. So how do you manage emotions that are being conveyed through text?
We don't, and I would recommend that you don't as well, because this is such a, it's a very, very, very difficult task. Like most of the models, they are pretty much crap, and for the most part, depending on what you try to achieve, you're gonna be better by using some kind of another feature. But if you want to try to, you're going to get a labeled dataset, and I recommend that you label the dataset on your own, because most of the stuff that's published out there is very badly labeled, like 20, 30, 50% of the emotions data is actually labeled pretty badly, so you need to do it yourself as well. All right, how are we with the time? Because I believe we have another
Yes,
talk coming up.
yes, we have another talk, so thanks a lot.
Thank you.
Should we just get started? So I'll get a thumbs up. So if anybody from Maersk watches this and who is like a brand person, I'm sorry that it's not the official, font of Maersk. It's because it's apparently running on Keynote now. And obviously at Maersk we have Microsoft, so it's a PowerPoint presentation. So I'm sorry, and because I know I have some Maersk fans here. So I'm Micha. I'm working in the forecasting team of Maersk. I'm working on the service delivery platform, and that only means that basically what we are concerned with is the operations of like all the vessels. And as you probably know, Maersk, we're a pretty big company, so we have a lot of vessels and a lot of containers to move around. As you can see here as well. So what we do from day to day is that we do forecasts on like where will containers need to be moved from to where, and where need empty containers to be in the future, so we don't have equipment shortages like we have today, for example. Those are not made by us, but they are there, and we have supply chain issues. I'm not going to try to convince you otherwise. Forecasting at Maersk. So Maersk, as you probably know, it's a very old company. I think 117 years this year. So it's has quite a long time already since it's alive. And it is undergoing a rapid digital transformation. So you don't have to wear ties anymore, and you don't have to wear suits. And it's very different from what it used to be. At least that's what I hear. I've only started there 2 years ago, so I'm a relatively new addition. But it's really rapidly changing in the sense that we have like thousands of engineers working on different types of products. We have a lot of actually, machine learning applications, and in our case, it's forecasting. And if you do forecasting for what I just showed you on the slide earlier, right, this kind of operations globally, well, you kind of need reliable data, right? You kind of need to have high quality data because, doing a forecast wrong is actually detrimental. We have 5 products that are in production. They're used day to day for planners globally, so we can't just give you 5 times the volume forecast that it's wrong. We can't really do that, right? So we do have to tick all these boxes, and at the same time we have to have a high change velocity. I mean, today we are our team is mainly focused on the ocean, but as you might have read, we've also acquired a lot of kind of air freight brands and e-commerce, warehousing, trains. So we kind of do everything these days, and we want to integrate all these logistics for everybody in the world. And that kind of means that we have to really change the way we do things, and we have to be faster at doing forecasts for different things and different modes of transport, for example. And it's data engineering meetup, but I hear not so many people are data engineers. So maybe we can do a show of hands, like how many people are data engineers or people who are technically working with data. That's pretty good. I would say 50%. That's good. So I know you guys love tech. I love tech. I don't really care about technology actually, but I do like it, if that makes any sense. And our team, we love open source. So we, it's just kind of some stuff. Also stuff we run is we use Spark, but we actually run open source Spark and Kubernetes. So no data breaks or anything. We use Python a lot, like Pandas, for example. We use R for running the Remax models. We use a lot of Kubernetes. We use managed Kubernetes and Azure and blob storage, make Bash, Docker, Terraform, all the things. And we also use actually Datadog. So it's one of the few paid things we're using. So not much there. Also no databases, just because somebody asked about storage and stuff. We don't use databases, but we still kind of are able to deliver 3 million forecasts a day. So it works out, which is good. So yeah, back to forecasting again. Just to kind of get the scope for today, I'm part of a product team, the forecasting product team in service delivery, not part of a central data team. I was already asked today if I would be part of global data and analytics. I'm not, so I'm not part of that part. I'm really part of a product team. What we do in this team is that we build all our pipelines more or less from raw data. So think of CDC data, Oracle Golden Gate messages, all the way up to actually delivered forecast. So that's a lot of transformations, a lot of massaging until we actually end up with a data product. And that data product is then kind of given to different kinds of product teams that are working for the planner. So there might be another application that is used where our forecasts are embedded, right? So there's no dashboards. We don't do self-serve analytics or anything of this kind. We're delivering these machine learning forecasts, and they're getting embedded into the kind of ecosystem of Maersk right at the core. Yes, and so I gave a talk about data ops in Stockholm recently, and so this is kind of a bit of a rehash of the slides. And one of the jokes I was trying to make is that we actually never talk about data ops in our team, but it's actually very important. So if you look at what data ops is after this, I don't want to bore half of the people here with what data ops is. Look it up. I think it's very helpful if you work with data to just think about this. We never talk about it, but it's a very good idea to work like this. Because you want these things, and this is exactly what you get with working in a data house way. What we've achieved in our team in the last, I would say, 18 months or so, we've done. So when I started in March 2020, just before Corona, I was the first data engineer in the product team. So we have like 5 software engineers, 5-6 data scientists, and now we have 3 data engineers in total. What we managed to do is that we managed to crank up the reliability data delivery from like 75% to 99%. That's partially because of the way we work and the way we handle our data, but it's also because we insourced a lot of the responsibilities. So a lot of the things that were used to be with a kind of a business intelligence function before, we kind of insourced that to run the pipelines ourselves. So it's kind of a mix of like how we organize, but also how we build. We've also implemented in the last 18 months a fully systematic data validation system, and that has helped us to prevent serious data incidents. So like one of the things we found at some point in time when we were relying on a service like a SaaS data platform to kind of crunch some numbers for us, kind of some legacy stuff. So if you work in enterprise, you have like a million systems. So one of these systems turned out to have a race condition, and that meant we had like corrupt data which didn't look corrupt, right? And so we were able to kind of kick that out. And that's some serious money here. So this one point here, it looks so small, but actually preventing that is like tons of money for us saved. It's really hard to go to stakeholders and say, look, we're saving money by preventing. It's not very sexy, right? It's not like sexy like a machine learning model, but it's absolutely crucial if you want to do data engineering at that scale. And the other thing we're focusing highly on is a high change velocity. So the way we work is, and I'll talk about that today, is to kind of be fast in actually changing things in production. So we have 5 products, but we have like lots of shadow pipelines as well running. And we typically make like 1 to 10, sometimes even 20 changes in production a day. And that's important because we have 5 data scientists. We have a couple of different products. We need to change those all the time. And they need to work still, right? And yeah, as I already said, we have like roughly 3 million forecasts a day that we're delivering on a daily basis, right? So they are not real-time inferent, they are batch, but it's still 3 million forecasts a day. High change velocity. How do we get there? Or like, what are the annoyances of high change velocity? Why do you need it? So, if you work in enterprise, a lot of these things are probably familiar. If you're asking somebody for new data, it's it's going to take 3 months because I have to call Oracle and do the thing and get the table in here synchronized to ADLS. That's really shitty, right? You don't want to be in that situation. Or somebody tells you cannot change this because this guy implemented this transformation. Nobody knows how it works. There's a 120-step SQL thing. Like don't touch it because you would break the world. Changing that. And that's kind of sad because you really need to change. You really need to change fast in order to deliver value, to figure out how to deliver value, because let's face it, like these products I'm talking about, yes, we have them in production, but they took years to build, partially because of these kind of sets of frictions and this kind of way of working with data, which took way too long, having very fragile ways of working with data. But lo and behold, there are people who can change code and who can change products very fast. Those people are called software engineers. They have really good practices, right? So I'm listing some of the things we're doing, and it's basically just software engineering, right? Everything is code, everything is version controlled. We ship continuously, so we ship like every day, as I said, change to production, no problem. We have a lot of tests that are automated. All our deployments are automated. Our environments are also automatically created and disposed of. We actually don't have so many different environments. We mainly have production with feature tokens, and then we have some kind of disposable environment that we use. And yeah, just to step through that a little bit, automated tests. So if you look at it, can I point with this actually? No, I can't see it. If you just look at a data pipeline, and just some schematics here, it's like if let's say you have a file in your bucket or blob storage or whatever cloud you use, right? You have some job that's built out in your file. You can test it, right? So you can have this one here to test this pipeline. It's actually super easy because it's very functional. You just have an input. You can test what the output is, or you can test like some certain transformations in it if you want, right? All the stuff. But you can actually test like the whole thing, right? If you generate data for that, you can do that very quickly within automated testing, and you can test if something changes in this job, or something changes in this job. I can easily see if that breaks. I don't have to wait a full day to see, what happens. Don't have to go through deployment necessarily to see if it breaks, which means it helps you to change your data set. Right now, imagine you have like 100 steps, maybe not 100, but maybe 15 or so. That's roughly what we have until we end up from raw data to the forecast. That helps you a lot by doing that. And I'm saying that here, knowing that our code base is not always having tests everywhere, right? But it's something that we're working towards. I think the last 6 months we've been building like this. But it's not that, we have a lot of legacy as well internally, so it's not like all perfect, of course, on our side. If you're doing automatic testing, who's doing automatic testing with data? Shaky hand, 1 hand, 2, 3, 4, 5, maybe?
There was
Okay.
2 hands, not 1.
Okay. Don't use static files. We've also done it. We'll break your neck eventually. It's a big anti-pattern. So you spend some time to use generated data instead. What we do we try to do things very simply. I showed you that we're using Spark, but actually we prefer to use just pandas if we can, because why would you use Spark if you don't have to? But essentially most of the stuff we run is PyTest to run pipelines and everything we have to test, right? So there's no secret sauce here. One thing we've been doing to get these end-to-end tests to run properly and automated is that we have like some schema classes that is kind of a quick fix for not having static typing in a way, right? So if you would have static typing, you could very easily test like all these downstream dependencies. So but you can make that very easily. It's not actually a lot of work to do that, and you can do all these tests, and you can test like schema evolution and how it works in CI, right, without any problem. And in the absence of having to evolve your database as well, or your data warehouse, you don't have that headache as well. You don't have to migrate that, because I'll show you in a second like how we think about data sets. The other thing is automated environment creation and orchestration. So the problem often becomes that if back in the days at least, when you want to change something that sits on the foundation of your stuff, right? Let's say you have one data set that is I'm looking at banking circle people over there. Let's say you have some transactions, some financial transactions, and now you say, okay, but actually the first transform that gives me like clean data, I want to change that, but everything depends on this data set, right? How do I make sure that this works at the full scale, right? So maybe I trust the test, okay, but maybe I should still see what is actually changing in the end, right? So you want to have a way where you can maybe make changes at the first one, run the whole thing without needing to do that manually, right? You want to do this as automated as possible, and then you make it, you get the delta of those and see what happens. And in order to do that, you need to automate that, because otherwise you're spending these days and weeks and just rebuilding the whole thing in Shadow. You don't want to do that, right? You want to have that easily. We used to do it with feature branches. Now we have feature toggles. So these things, we have a way of, and we can talk about that after the talk if you're interested in how we do this. But essentially we say, well, just run a feature toggle on this one job, and then it runs all the downstream stuff, and it will just run in production, and we can just do apples to apples comparison, and then we switch over if we want to cloud. And imagine doing the same for machine learning, right? You say, I want to have these 5 different things, I run 5 different features, and I just run it, and I can compare apples to apples afterwards. It's really, really crucial for experimentation and being really sure that you're getting the right thing out here. Reducing waste, very good these days. So one of the things I've seen in the past also is that people spend a lot of time on having like 5 different environments, or spending half a year on building a model and then trying 2 years to put that in production, and that's also pretty wasteful. So we like to think of not productionizing things. We like to think of building things at scale, and also not having like all these having a staging environment. That might be important if you have for example, a UI or something. But in general, data is not really necessary, right? Namespacing things is perfectly fine, and you don't want to have like, let's say you have a dev environment that has to have all the data as prod, you don't want to have a copy of that, right? You don't want to have the headache of dealing with another set of environments that you don't have to have. Because in the end, the only thing that counts is actually if it runs in production or not. So you'd rather have a shadow run in production, make an apples to apples comparison, and be done with it, because that's what counts, right? Nothing else counts. So there's no point in running development in a way. I'm being very provocative, but think about that for a little bit, and it works pretty well for us. So what we do is we experiment in production with dark pipeline. You can call it dark pipeline, shadow deployments, feature targets, whatever you name it. But this helps you a lot. Okay, high quality data, and that's kind of close to my heart because it's something I've been working on a lot actually. And one of the nicest quotes I heard in the office was, "The quality is fine. It was validated in 2017, right?" So that happens a lot, right? You look at a data set. It's huge because you're looking at history since 2015, and yes, we have quite a bit of data. So you do this exercise where you Excel sheet back and forth with the business and say, "Oh, is this actually correct?" or "What did the container move?" or whatever it is, right? That only brings you so far. And 4 years later, it will probably have changed, right? Especially if we're modernizing our systems. So you really need to have some systematic testing of your data quality. And there are, of course, different ways of doing that: synchronously, asynchronously, you name it. But in the end, for us, because we're delivering these forecasts fully automatic, so ideally we don't want to wake up and say, "Oh, we actually do this really bad forecast over the weekend." That's not really good, right? So we kind of want to stop those things. That's a decision we made, but depending on where you sit in the organization, might not make sense for you. So for us, it's really important that we prevent bad data from producing bad outcomes. And so we have this kind of control thing. I showed you this kind of data job thingy before, like green being like the data set, blue is the job, and then the yellow thingy, that's kind of it's actually just generic compute that you can run. But in our case, we use great expectations to basically validate data. And so it can break the data if it doesn't fit a certain validation. So a certain distribution is off, certain values are off, or something else is off. And if we can do that on destination, most of the time we do it on output, but we can also do it on input for certain reasons. But on the output, for example, we also kind of, if it fails, we will still keep the data around. We will not run the pipeline further, or we'll stop it, we'll save the data, and we can come in and inspect, like, okay, what actually came out? Was it actually wrong? Because once you start the journey, you quickly realize that, well, what you thought the data is, it's actually not the data. So you have to adjust your thresholds or your kind of ideas about the data. And that's probably something you have to do constantly. At least that's what we have to do constantly. You can also do asynchronously, and if you do it synchronously like we do, you can actually just collect the metrics to key value store, or Datadog in our case, right? And you can observe and monitor, like, how did the data quality evolve? And when I say data quality, a lot of times, if you don't know anything about the data, you cannot do much more than cardinality, null value counting and stuff like this, right? Or you look at some correlation of the data. That's really all you can do if you don't know anything about the data. Of course, we know much more about the data because we're a product team, so we have a lot of kind of very specific kind of expectations towards our data. So those would be saved in logs, so we can look back in time. Did it change? Did it not change? Is it bad? Is it good? Well, and then you have to spend the man time to actually learn, iterate, and improve. And a lot of times, people will stop complaining and they will put this in place and all data is bad. And all data is bad, but you need to learn to prevent that, right? And so every now and then we find something, we detect something, we have to fix it, and then we put measures in to prevent it, right? That's just how it goes. And again, that kind of feeds back to this, one incident a month. A lot of times we don't know anymore what it would be because we're preventing so many things and have already prevented so many things that we don't really know what that is. Like, it's hard. It's very kind of counterfactual to think about what we save in terms of money by doing that. But we know that it is crucial from our past failures, so to speak. Okay, let's say you can do all of this, right? You can easily change your things, you can deploy everything, you can build scale, that's fine, and you have good data quality because you have good checks and you're preventing bad things from happening most of the time. Not all the time, but most of the time, hopefully. Reliable data delivery is also really important for us, right? So we can't just say, well, we deliver your forecast probably a day or on average every day. That doesn't really work, right? So our consumers, they need to have data like every day. They need to have a fresh forecast. Of course, if it's a bit late, maybe that's not a problem. But you have some SLA, and you need to stick to that in order to make that worthwhile. And the other thing is also that things that happened that I've seen happening before was someone in your team runs the model on some data set. And then the other person runs on the next day, runs on the same data set, tries to run the same model, and something else comes out, right? Because if somebody mutated the data in the night, right? If you're using a data warehouse and just updating and merging and doing all those things, you have no data working, you have no control over like what is coming through, right? And what is like if I run it today, it's kind of the same, or the analogy for software engineers would be, yeah, it runs on my machine, right? That you can absolutely not have that happening, right? And I think so. The previous speaker, she said, when do you put these things in place? And I mean, I totally agree. Don't put them in place if you don't need them, if you're just starting out, right? But once you start out, right, they become crucial within like no time, right? So it's really good to think about that, even though you don't need them. So I think it's it's really good advice. Okay, so the things we do to crank up our reliable data delivery is that we follow functional data engineering practices. I'll talk a little bit about what that means. We spend quite a bit of time on orchestration, workflow management, and on the reproducibility and debuggability of our system. So functional data engineering is, in my eyes, key if you want to do any kind of science, right? You need to make things reproducible. So if you want to make things reproducible, you have, in the science world, your data has to be reproducible. It's very, sorry, it sounds very trivial, but it is very trivial, right? There's no really kind of secret I'm telling you here. But what we decided to do is to do something super stupid and super dumb. If some people think this is dumb, and I agree, it's kind of dumb, but it actually works, so it's good. What we do is we have, let's say we have some source data, and we call that a snapshot 1. We just run a job that puts out a new set of data, right? So it's a destination set now. So it's not overriding this one, it's just making a new file, somewhere in the bucket, in the blob storage, wherever. And then we just label that, and of course we keep track of, what was the code that ran, when did it run, all the metadata, the whole provenance of everything, right? That's very easy to do if you have good workflow management. So we do that. Next time the same job runs, we just do the same thing, we just have a second snapshot, right? And I mean, if you run a blob storage, you can do that up to hundreds of terabytes, and you spend a couple of thousand a month. It's actually not so expensive if you look at what you pay on some other managed services sometimes. So think about that. I think if you don't have this kind of reproducibility, you're kind of screwed already in the beginning. That's something I would do. In the first place I would do is following this, but you can do it by hand, obviously, right? Orchestration. So one of the things that I've also experienced in my past is that orchestration can be really hard if you have to collaborate with people. So if you have a centralized team and you have 5 super skilled engineers working on Airflow, I mean back then it was Airflow 1, right? That's okay, you can manage. But let's say we hired new starters from university. We have data scientists. We have some data scientists who are not really good with computers. Right? They're very theoretical. We have to make this easy for them, right? And since everything is code and everything actually runs process through Git, right, it has to be so easy that it has to be basically just a file thing where people can just put it in and say, just run this, and not look at the whole DAG of things, but just look at your job. Let's say I run this model, and I always want to run this model or this inference if the upstream job changes, right? And that's exactly what we have as a system. So you can just say, well, I can build all the data, it's all fine, and my colleague will just come and build these models and say, well, I just run this every time the new data arrives, and don't think about cron, don't think about DAG, don't think about how to deploy that to the Airflow central server. Don't think about this, right? This is how it should be, because otherwise, I will just be there holding their hand while they try to deploy this model, while actually I want to run 5 different features on another data set. So I have to really do that. Anyways, self-healing, observable orchestration. So yes, you also need this overview of DAGs. If you're data engineer like me, you like those things. Things run, things don't run. You have to fix it, fine, but you need to understand it, right? So having something that is observable is actually really hard. And another thing is separation of concern. I already talked about this, so there's not much here, but it's more like design philosophy-wise, what we try to do is, as I said, we have a file, we have some logic that has no time and no randomness, so it's easy to test. So the way we like to build our logic is basically using test-driven development, and build out these logics, and then we have the logic code here, And then we have these checks. Those are more or less parameterized these days. So it's just if you use great expectation, there will be a JSON that you have to produce that tells you something about data set. You put it in, and it will run these checks automatically for you. So that's what it is. But the point here is that you want to get rid of, like, for example, freshness. So freshness we would check here, because if you also build in your freshness checks, because that's also important for us, then you get into the problem that it starts to be hard to test, right? Because then if you run something against the system clock, it's always bad. Right? You never want to do this because it kind of hurts your testability. So maybe that's a bit too deep into the technical hole, but I'm happy to talk about that and the design decisions behind that. And with that, I'm actually done. So if you put all of this together, you hopefully are able to get forecasts that tell you roughly correctly how many containers should be on that ship at the right time at the right port. That's it. Please.
So you mentioned that you do around 3 million forecasts a day?
Yes.
Something like that. I assume that you have multiple models. It's not one model doing all the forecasts one day. So what is the underlying assumption for the difference between models, right? So I guess, not knowing the data, but I guess you have different use cases for these. And what is the underlying assumption that divide these models?
So that depends on the product, but essentially every product that we have has some model selection step that actually runs every day. So depending on like what the time series is and how it looks, it will make some decisions on what kind of model it will use. So, but typically, or without saying things that I don't understand or that I have not worked on, what we see is that we have certain regions, like for example, or certain ports, like say Shanghai and Rotterdam, those are highly used ports. They will use a different model than very sparse ports, right? So you often actually will end up where you have like not so much knowledge. You would just have a moving average model because there's not much you can do, right? But then for other things where there's more seasonality and there's like citrus season in certain areas, right? There would be certain models that we would pick there, but those will be picked on some metrics that I'm not deciding on because I'm the data engineer. But yeah, that's roughly how it looks.
How did you achieve self-healing data pipelines? Because you kind of jumped.
Yes, I jumped over that. But so essentially, the way the orchestrator is built, that's an in-house project that I actually I'm not the founder of this or anything. Is that they will run, and if something goes wrong, they will just retry. They will just keep retrying. And self-healing basically also means that you're not relying on the kind of a cron schedule. So if you have a cron schedule that relies on, let's say, you have two pipelines, A and B, that depend on each other, and A runs at 10 o'clock in the morning, B runs at 12, but for some reason, because there was not enough resources, A didn't actually run until 1 o'clock, like 13 or whatever, so it actually took the old data, or it didn't run, or it failed. So we built a system such that it actually will recover from that. So for example, if we have on the edge data, which is kind of data we would ingest from the central data lake, if that goes stale, the first one will break, right? But it will keep trying, it will keep polling at some rate, and as soon as the data is fresh, it will just start the whole thing up and it will run the whole thing without intervention from the human. And it's actually it's very simple because it relies on, so every data pipeline for us is two things. One is an image, or one is a job in Kubernetes, and the other one is a deployment of a service, and that service constantly polls. It's like a tiny service, it just polls the input data sets that are specified, and they will check based on your scheduling strategy what it should do, if it should run a new job or not. If it should run a new job, it will just spin up this one. And then this will produce new data, and if that produces new data, another one that is polling that data will then run. So it's kind of a choreographer more than an orchestrator actually, or self-orchestrator. But it means that it kind of recovers itself. Yes?
In one of the slides, you said that whenever data is bad, it kind of breaks the pipeline. Did I understand?
That's wishful thinking. You understood it correctly, but it's wishful thinking because, of course, we don't know magically when data is bad. But there are a lot of situations where we do know when something is bad. Things that we have seen before, or things we've made a guess on. For example, let's say if there's a million containers on one ship, it's probably bad, right? Because that's really not a good value. But yeah, we don't know that magically. One of the things I didn't really mention, but So these validations, those are generic compute. So one of the things I've done, and we have like these creative hackathon things where I've done is where I used Profit to, Profit is crap, but maybe it's good for data quality, who knows? But but basically to do like on the time series, do a forecasting and if there is an anomaly, right? Because that's something would be the next step to do to figure out like without knowing anything about it if something is bad or not. But I don't have high hopes for that one currently. But it would be the next thing to do something about bad data without knowing if it's bad or not. Like knowing with a threshold or knowing with some certain kind of configuration up front.
Thank you for the elaborate answer. I actually wanted to continue my question. It was mainly about the process around whenever you have bad data and that kind of requires manual intervention. What's your process?
Yeah, so the process is that like everything that fails goes into the failed bucket. So the person who is on support will pick up.
Okay.
So that could be a software engineer, it doesn't really matter. So for us, it's the same, right? If it breaks because of bad data or breaks because bad node in Kubernetes or and it could be million things why things break, right? This will be fixed by that person. And if the person needs help because it doesn't understand if it's a data thing and this person doesn't understand if this value can be changed because it might be false positive, right? You need to adjust the threshold. So that will be one outcome, right? You need to kind of figure that out very quickly. Or on the other side, you will halt it and you have to debug where it is because it really depends on where it is, right? If it's our transformation, might be we have to put in some code to handle some edge case. We actually had that recently where everything got stuck because somebody put in a date that was 0001 in a source system, which actually shouldn't have been possible according to the source system, but it was there in the database, so everything got stopped. So then we have to fix those things with code upstream. But the process is basically like any software engineering process, right? There's a bug, it's time critical, you need to fix it. So sorry, that's not. I have a slide for all the outcomes in our README. I can show you that, but it's really more like a flowchart for decisions. But basically, it's false positive, fix the threshold, otherwise go figure what to do.
You mentioned Datadog. Are you all your monitoring, is that placed in Datadog, and where do you actually, what process do you have built around the diff? You said you have a shadow or dark pipeline, yes. And then you do a diff. Where do you do
so
that?
The diff, that's typically something we do by hand. So there's a lot of automatic monitoring we have for things failing, and there's also a lot of. So we recently started using a file stream, so we have certain alerts set up for all these jobs that are streams. Let's separate that out. So Datadog we use like any other software team, right? We just use it to see if things are failing, also for data things that they are failing. But this diff thing is more that we don't really alert on the difference because we really don't know what we're expecting, right? This was more to elaborate on the fact that if you want to make a change, right, you need to figure out that this change is making the change you wanted to make, right? But it's not something we would alert on. It's more something that we would then check as part of the development effort, right? Sorry if I've been unclear. I think there was it.
Maybe you first. It's probably related.
A little bit.
Yeah.
You mentioned two things that got my attention. First one is reproducible environments.
Yes.
That sounds really like a really good idea. But then you also mentioned hundreds of terabytes.
Yes.
Do you reproduce the whole data in the new
No. I mean, so when I say reproducible, I mean, so if I said reproducible environment, what I meant was not reproducible environment. What I meant was having reproducible data and data pipelines, and then disposable environments. So everything that is not prod for us is completely disposable because there's no fixed development environment. We don't want to copy and have a copy of prod. We don't want to manage a subsample of whatever. We just want to have production. And what matters for us is that things run in production, or they run against production in the right way, or have a diff in the right way, and then they just get promoted, but not promoted in the sense of through an environment that is managed, but more like a feature flag or a feature topic.
Thank you.
So did I answer the question?
You did.
Good.
Yes, so coming back to data quality, so you mentioned bad data, bad outcome.
Yes.
I think it's something we've all seen. And then you talk how you significantly improved the data quality, and it sounds like you're spending a lot of effort on that, right?
Yeah, I mean, I think more. We've been thinking about it quite a bit, but we don't actually spend a lot of manual effort on it. I mean, the key is not to, you don't want to spend manual effort on it, right? You need to go into the cycle where you start preventing that.
But basically, you've put a lot of effort either in code or whatever.
It's actually not hard, it turns out.
Okay.
So the POC we did, or that I did actually back in the days, about half a day to get something running. Then we spent 2 days making a wrapper for all our pipelines that was kind of just configurable. Then we spent, I think, a week or so with 2 people, so me and a software engineer, doing all the profiling and all the sets for basically 90% of our data sets. And recently we have upgraded that into a package in our orchestrator so that all the other teams that are using our stack can also use that and just run arbitrary compute. Mainly
that was my question actually. How do you share this data quality effort with the other teams? Do you treat data as a product within the organization? Do you have a data catalog where you have
so
this is clean forecasting data, use this guy, this
well,
back to the warehouse?
You can ask my colleagues, I don't know. So we don't have like so much cross usage of our data, right? There's no analysts also using our data directly. There are some teams, so we have some, like Team Tsunami also, they use some of our data. And they are the benefactors of basically we give them quality assurances of this data.
Yeah.
But it's not that they benefit from it otherwise. But all the other teams who are using our orchestrator, they have the ability now to run these data checks completely automated. So the only thing they need is a JSON file that is compatible with Great Expectation, and it runs it for them, right? So there's some sharing of like technology. That's one thing.
Yeah.
And through the data, it's very limited. This is mainly for our team because our scope is not to kind of give all the data to all the organizations. Also, the organization is very heterogeneous, but also, I mean, we have very specific needs to data as well, which is why we also go very much to the raw data, because the way we have to model our data is that we have to do like historical time series of how bookings evolved over time and volumes evolved over time. Those are not things you would normally see in a warehouse where you might see latest state of something, right? So.
Yeah, but I can imagine there's going to be new product teams coming up. I mean, it's Maersk,
Sure.
right? You're doing a digital transformation every 3 years.
1.5.
No, but I think it's not unthinkable. I was also
Yes.
Maersk. I'm not.
I know.
So I think it's not unthinkable that another product team further down the line is going to do exactly the same steps that you're doing now, the same thing, the same. So it's more about the reuse of all of this valuable information that we have.
Absolutely. I mean, I said that we do that minimally, and that's true if we look at how much data we have. But we do even serve a data API. So everybody at Maersk, everybody who has a subscription within the Maersk resource group in Azure, can in principle use all our data. It's completely there with all the snapshots and everything, and you can just access it through an API. So it's all there, but it's just that.
Maybe I can give a comment here. I think it just not only Maersk, right? I think that it just I don't know for a company this size that many teams when they develop something they don't want a lot of dependency to other teams, right? I think like you said in theory people can use it, but the thing is in the future if they build product on top of that, and then they dependent on you basically, right? Like if they need something different, if you change something.
The data set can actually become a product of its own.
Of course, but the thing, like I said, the more dependency you have, the more alignment you need, right? The more, when you build your roadmap and stuff like that, that's the last thing you want, right?
But it looks like this is turning into a conversation, so I would say the food is here. Let's give it a hand.